An encrypted phone number. Using Caesar Cipher.
Hey there. I am Greg Heffley. I am in middle school and we are hosting a dance very soon. I just have one problem. I am terrible at talking with girls. There's a girl in my class named Holly Hills. I think she would go with me. If I only had the courage to ask. I met her at a cybersecurity workshop I attended last summer. We have common interests in cryptography. What is cryptography? Well, that's simple. Cryptography means secret writing. I am too shy to talk to Holly in person, so I will pass her a note in class. I am going to write Holly a note asking if she would go to the dance with me. Can you pass this to Holly, please?
Sure, Greg wants you to go to the dance with him.
That's nice. I will write him a note back. I would love to go to the dance with you, Greg. I would write my number on this note, but the student between us will read it. Can you pass this to Greg, please?
No problem, she is right. I will definitely take her number down too.
I think cryptography will help us here. The student between us keeps reading our note. Holly and I have to use cryptography to secure our messages. To do this, we will use the Caesar cipher. The idea of the Caesar cipher is simple. Assume there is a safe box with a lock and a pair of keys. A sender can use one key to open the safe box and drop off mail. A receiver can use one key to open the safe box and pick up mail. I am going to ask Holly if she remembers the first key we learned at the workshop. Do you mind?
Not at all. Key? I have no idea what he is talking about.
I do remember. Looks like I can send him my number. Here you go.
This message does not make sense. Here.
Yes. I have Holly's phone number. How could Holly prevent the student between us from reading the phone number? Holly uses one of the simplest forms of encryption called the Caesar cipher, also known as the shift cipher or substitution cipher. It is performed against the 26 letters of the alphabet. Each letter in the original message is replaced with a letter corresponding to a certain number of letters up or down the alphabet. Here is the Caesar cipher encryption of a message using a right shift of 3. The cipher replaces the letter A with the letter D, the letter B with the letter E, the letter C with the letter F. This shift continues with the rest of the alphabet, until finally, replacing the letter Z with the letter C. The original message is called the plain text. In our case this is Holly's phone number. The information that is unknown is called the key. In our case it is the first key Holly and I learned at the workshop. The process of using the key to convert the plain text is called encryption. The text that is generated after encryption is called ciphertext. In our case, this is the text the student between us could not read. Finally, the process of using the key once more to convert the ciphertext back into plain text is called decryption. This would be completed by performing a left shift of 3. That was a lot of information. Let's relate what we just learned to Holly's phone number. Let's begin by saying Holly's phone number is 21098765443. We will use the English synonyms of the phone number. This is our plain text. Our key is a right shift of 3. Encrypting this plain text using the method we learned previously creates this ciphertext. Finally, using a left shift 3, we decrypt the ciphertext. This reveals the original message. Performing these techniques on larger scale messages can become overwhelming to do by hand. We can implement computer software into our cryptography practices. The software we will use is called Sage MathCell. Sage MathCell is an open source, scalable, and easy-to-use web interface to the Sage mathematics software system. Let's try it out. The Sage code is a bit complex for people unfamiliar with programming. The output, however, demonstrates that same results that we uncovered by hand. This involves inputting Holly's phone number, then using the string as a parameter within the enciphering function, creating the ciphertext. Then the ciphertext can be deciphered. The top text box is the area where the code is written. Once the user has completed the coding, press Evaluate, then Sage will return your results. This is a simplified version of the Sage code. This code will place our input, Holly's number, into the enciphering function. The first line stores the shift crypto function containing alphabetic string characters as parameters into S. The next line defines Alice's phone number. The next line encodes the phone number and stores it into P. This line sets our key to 3. This code uses our key and encoded phone number as parameters to generate our ciphertext with a right shift. The next line prints the ciphertext. Finally, this code deciphers our ciphertext stored in C and prints the original message. I was able to use my knowledge of cryptography to solve my problem. Now I will be able to take Holly to the dance. Thanks for watching.